Alright, in this lesson we will continue to learn about solving logarithmic equations such as these. These are the next level equations. Some of these will involve solving quadratic equations and more advanced techniques like that. Please put your pencils down. Do not copy off of me. Watch what I do, learn how to do it, and go back and do it yourself. Alright, well, let's start off easy peasy lemon squeezy. If you have the logs the same like this, there's the one-to-one rule of logarithms that says that we can drop these logs out and set the arguments equal to each other. So 3x plus 2 will equal 2x minus 1. And we will just solve this like we learned back in middle school. Subtract 2x from both sides. So that will leave us with x plus 2 is equal to negative 1. Subtract 2 from both sides, and we get x equals negative 3. Alright, not very advanced, but just you wait. Now, looking at this using the same type of technique, we have log base 3 and log base 3 on both sides, so we can drop those out. And so we've got x squared minus 1 is equal to x plus 5. Now you see the x squared and the x. This is a different kind of problem. There's no way to get x by itself. So what we're going to do is get everything on the left side of the equation. Let's subtract that x from both sides. Now you can't really subtract x from x squared. So what you do is you just write them next to each other. So x squared minus x, and then just bring down your minus 1 equals 5. Now we're going to get everything on the left, so let's subtract 5 from both sides as well. So that's going to give us x squared minus x minus 6 is equal to 0. So what we are going to do to solve a quadratic equation, meaning we have the x squared term as the highest exponent, we're going to factor. So it's been a long time since the beginning of the year when we learned how to do this, or at least reviewed it. But factoring is never going away, so just accept that. So when we're going to factor this, we start by looking at the x squared, and we think, okay, x squared is x times x. Forget about the middle for a minute. Let's jump over and look at the 6. As we look at the 6, and let me change colors for a second. As we look at the 6, we're asking ourselves all the ways that we can make 6. We're thinking that could either be 2 times 3, or it could be 1 times 6. Those are the only possibilities. Alright? Now, if we go with the 2 times 3 option, the key is now we look at the middle. Alright, so focus your eyes here. Understand that this negative sign is like a negative 1. And what we need is the inner and the outer have to make the middle. So here's what I mean. Inner, we have 2x. Okay, if I multiply those. Outer, we have 3x. Together, they have to make the middle of negative 1. So, is there a way to get negative 1 out of these if we choose the signs right? Well, yes. If we had a positive 2 and a negative 3x, that would make negative 1x. So let's make that happen. So positive 2 and negative 3. We always have to check one last thing. We have to check the last term, the constant. Does positive 2 times negative 3 make negative 6? Of course, it does. So that's how we know for a fact that we have factored this correctly. Normally I would erase this, but I'm going to leave it on there. So now what you do is to find the solutions, you need to, let me just set this apart. You need to set these two factors equal to 0 and solve. Okay, so we're doing x plus 2 equals 0, and we're going to do x minus 3 equals 0. So of course here we're subtracting 2 from both sides, so that gives us x equals negative 2. Alright, and over here we are adding 3 to both sides. So that's going to give us x equals 3. Now, remember, you cannot take the log of a negative number. That does not mean that negative 2 is automatically extraneous and we're going to throw it out. What it means is we have to plug it back in and see if we get a negative number after we plug it in. So let's look at this negative 2 first. If I plug in negative 2, alright, imagine I put a negative 2 right there. What's going to happen? Well, I will have negative 2 squared minus 1. Well, that is 4 minus 1, which is 3. Okay? So far, that's fine. Now, we need to make sure we're getting the same thing over here, though. Over here, if I put in negative 2, then I will have negative 2 plus 5, which again is 3. Okay, so that solution of negative 2 is just fine. I get the same answer both times, and it's positive, which it needs to be. Let's check the other one just to be on the safe side. The other solution was 3. If I put in 3, that 3 squared is 9, so 9 minus 1, that's 8. If I put in 3 right here, 3 plus 5, that's 8. So that's, of course, totally fine. So we just have 2 solutions this time, which it happens. So we keep them both. Alright, let's move on to number 3. Now, this one, the log is only on one side, so we're not going to drop out any logs, but we will use exponent form. So when we rewrite this in exponent form, we start with the base, which is 16. Alright, so I'm going to bring down that base. Now, in exponent form, there is no log. Okay, so we brought down the base. Now, these two parts are going to change sides of the equation. So the 4a minus 9 is going to wind up over here. The 3/4 is going to wind up over here as the exponent. Okay, now 16 to the 3/4 power. Alright, so 16 to the 3/4 power, that gives us 8. Alright, so I've got 8. So I've got 4a minus 9 equals 8. By the way, just real quick, let me show you how we could have done this by hand. Alright, please remember that when you do a fractional power, that's the 3 is the power and the 4 is the root. So you could have looked at this as the 4th root of 16 and then the power of 3. The 4th root of 16 is 2. So that's going to give you 2 to the 3rd power, which is 8. So that's where the 8's coming from. Now on your next test, you will be allowed to use the calculator, but you never know when in the future you won't be allowed to use the calculator. So it's good to know how to do it by hand. Anyway, let's go on and finish this up. So adding 9 to both sides, we have 4a is equal to 17, and then dividing both sides by 4. Okay, we're going to get a is equal to, and I'm just going to leave it as 17 over 4. Okay, so that was it for number 3. Now looking at number 4, aha, we have a sum of 2 logs over here. Now guys, you need to remember what we learned a while ago about condensing. Let's see, please remember this rule. If we did log A plus log B, we could condense that, and that would condense down to log A times B. Alright, so that's what we're going to do right now. Alright, this is like our A and our B. We're going to turn that into one log expression and multiply. Okay, so natural log, but we need to do x plus 7 times x plus 3. Okay. Now, since we have natural log on both sides, we can go ahead and drop those out. Alright, and so that's just going to give us x plus 7 times x plus 3 is equal to 77. So it's just a matter of solving this equation. Now, when you multiply a binomial times a binomial, you need to remember how to do that. So we are going to double distribute. So we're going to start by distributing the x. X times x is x squared. X times 3 is 3x. Alright, then we are going to distribute the 7. Okay, 7 times x is 7x. 7 times 3 is 21. Alright, and we've still got the 77 over there. Now, combining like terms, x squared doesn't have a like term, so that's just going to be x squared. But 3x and 7x, those are like terms. Together, that's 10x. And then just bring down your 21 is equal to 77. Alright, well, just like we did up here when it was quadratic and we saw the x squared, we got everything on one side with a 0 on the other. That's what we need to do now. So let's subtract 77 from both sides. Get everything on the left. So that will leave us with x squared plus 10x minus 56. Okay, and I'm going to need a little bit more space than this, so let me just recopy this up here. So I've got x squared plus 10x minus 56 equals 0. So now we need a factor. So x squared is x times x. Now looking at that 56, we are asking ourselves what times what makes 56, right? So that's either going to be 7 times 8 or 1 times 56. Let's see, it could be 2 times what? 28, or even 4 times 14. Alright, I'm sure it's going to be one of these that we need. So let's start with the 7 times 8. Okay, if we do 7 times 8, alright, remember, here's where the middle comes in. The inner and the outer have to give us the middle. Inner, we have 7x. Outer, we have 8x. Is there any way to get a positive 10 out of that if we pick the signs right? No. Actually, no. Alright, if I subtract, I get 1. If I add, I get 17. So there's no way to get a 10. Alright, so fine, that's not working. What else? 1 and 56, 2. Oh, how about the 4 and the 14? 4 and 14 is going to work. Alright, so 4 and 14. Because, again, inside we have 4x, outside we have 14x. What would the signs have to be to give us a positive 10? Well, if I had a negative 4 and a positive 14, that would make positive 10, right? So there's my negative 4 and there's my positive 14. One last thing. Do I get a negative 56? Does negative 4 times 14 equal a negative 56? And yeah, it does. Okay, negative 4 times 14 is negative 56. Alright, so that's how we know we have this right. So now it's time to go ahead and set these factors equal to 0. So in other words, x minus 4 equals 0 and x plus 14 equals 0. If we add 4 to both sides, I'm going to get x equals 4. If I subtract 14 from both sides, I get x equals negative 14. Now, we need to make sure that none of these are extraneous. Okay, if I plug them in, it's important that I do not get a negative number. If I plug in positive 4, then right here I'm going to get 11, and right here I'm going to get 7. And we would add and multiply, and that would get 77. So that's cool. No problems there. But here's a problem. I see a problem coming up. Negative 14. If I put in negative 14 for x right here, then right here I am going to get a negative 7, right? Negative 14 plus 7 is negative 7. And if I put in a negative 14 right here, okay, that's going to give me negative 11. Now it's true that once I add these together, I'm going to wind up multiplying, because of this a times b rule, and I will wind up getting positive 77, but that's too late. You are not allowed to take the log of a negative number. Alright? It doesn't matter that I would multiply later. It's too late. So negative 14 is extraneous. So you want to put a big X through it, and underneath it write extraneous. Alright, x equals 4 then is your one and only solution. So if this were a test, let's see, what number is this? Number 4. If this were a test and you had an answer line, on your answer line you would just put x equals 4. You wouldn't put anything about the negative 14 on your answer line, just only this. Okay, that was number 4. Alright, let's look at number 5. Alright, this is going to be a similar type of thing. Once again, remember your condensing rules. Remember that if I have log of a minus the log of b, this will condense to a single log and become division. So it will be the log of a over b. Alright, subtraction becomes division. So that's what's going to happen here, because I have the difference of two logs. I'm subtracting. So this will become a single log when I condense, be log base 12 of negative 6a over 1 minus a, okay, is equal to 1. Okay, so I condensed. Great. Now, I only have log on one side. So this is not one of those deals where, like before, when I had a log on both sides, I could drop those logs out. Instead, because I have only a log on one side, I need to rely on writing this in exponent form. Okay, so in exponent form, I start with the base, which is 12. Okay, there will be no log in exponent form. But these two parts will trade sides. The 1 will come over here as the exponent, and this fraction will come over here. So negative 6a over 1 minus a. So I have this. Of course, 12 to the 1 power is just 12. So now it's just a matter of solving this. Well, multiply by the denominator is the best thing to do. So I would multiply by 1 minus a on both sides. Okay, that way these will cancel out. Alright, what else? So you need to do the distributive property with this 12, so be careful. So that's going to give me 12 minus 12a equals negative 6a. So I need to solve this mess. Okay, so because I see a's on both sides of the equation, I need to get them together. That's my top priority now. So I will add 12a to both sides. Alright, once again, please do not have a pencil in your hand right now, guys. Don't copy what I'm doing. Go back and do it yourself after you get a clue from Burton. Okay, so we will divide both sides by 6. Kabam, no pencils. So that's going to give us 2. Alright, let's just make sure that's not extraneous. There are actually 2 things we need to worry about for this problem. See this fraction? You're not allowed to divide by 0. So whenever you have a variable in the denominator, you need to make sure that your solution would not cause a 0 denominator. Now in this case, what would a have to be to turn this denominator into a big old 0? If a were 1, I would have 1 minus 1, and that would be 0. Okay, if I put in a 2, I have 1 minus 2. That's negative 1. That's okay as far as that goes, but something to think about. Now, the other thing I have to make sure is I can't have the log of a negative number. If I plug in 2, am I going to get a negative number inside of the log expression? And the answer is yes. Right here, if I put in a 2, then I'm going to get negative 6 times 2 is negative 12. So I'm taking the log of negative 12. Can't do it. So I don't really need to go any further, but just for completeness, it would also fail here. If I had put a 2 in, that's 1 minus 2, and that is negative 1. Okay, so that's a no-go. So our only solution turns out to be extraneous. So let's cross it out, and let's write extraneous. And we're excited about it, so we're going to put an exclamation mark. Now, so the question is, what do we put on the answer line if there was one? If this was a test and it said problem number 5, put your answer here, what would you put? You would put no solution. Okay? If your only solution turns out to be extraneous, then you have no solution. Alright, let's try number 6. Once again, we are using the condensing rule that if we have log A minus log B, then that's going to condense as log A over B. So this would be natural log, okay, and that's A, that's B, so that'll be 4x plus 7 over x plus 3 is equal to natural log of 3. Alright, we have natural log on both sides, so we can drop those out, and then we have 4x plus 7 over x plus 3 is equal to 3. So, to solve this, let's multiply by the denominator. So if we multiply both sides by x plus 3, then the x plus 3's will cancel out. So we will have 4x plus 7 is equal to 3x plus 9. Alright, so this looks easily solvable. So subtract 4x from both sides. So that'll give us 7 is equal to x plus 9. Subtract that 9. So that will give us negative 2 equals x. Okay, we have to make sure this is not extraneous though. So first of all, make sure that it won't cause a 0 denominator. And it doesn't. Second of all, let's make sure that it won't cause a negative inside the log. So, gonna have to erase this. I need space up here. If I were to plug in negative 2 for x right here, okay, then that would be 4 times negative 2, so that would be negative 8 plus 7. and that would in fact be -1. And that's no good. Alright, we cannot take the log of -1. So right away that tells me that this is extraneous okay, and since that was my only answer, that means we have no solution. Okay, so no solution for number 6. Let's find number 7. Okay, better zoom out. Number 7 is a word problem. Okay, this problem is talking about the Richter scale. So let's remember the Richter scale formula is the magnitude equals, well, there it is. There's the formula for the magnitude, where E is the amount of energy released by the earthquake in ergs. So anyway, a moderate earthquake rated 4.9 on the Richter scale. Look, so that's the magnitude, guys. Alright, that's the M. Shook most of the northwest corner of Georgia, south to Atlanta. The epicenter was located, blah, blah, blah. How much energy was released by the earthquake? Okay, so they gave us the 4.9. That's the M. So that means what we have here is 4.9 is equal to 2/3 log of E over 10 to the 11.8. Okay, so we have to solve this. How much energy? Energy is E, so that's what we're solving for. So in order to solve this, the easiest thing to do, multiply by the reciprocal to get rid of this. We need to get the log expression by itself. So if we multiply by 3/2 on both sides, alright, that way these will cancel out. Now let's see if this will make a finite decimal, a simple decimal that does not need to be rounded. So let's see, 3/2 times 4.9. Okay, 7.35, that's fine. So what we have is 7.35 is equal to the log of over 10 to the 11.8 power. So now we need to get this E out of here, so we need to rewrite this in exponent form. That's what you do when you only have the log on one side. What is the invisible base here? That's right, invisible base 10. So we're going to bring down that invisible base 10 like so, and the rest of it is going to change sides. So the 7.35 is going to come over here. Now this is exponent form, so it'll be the exponent, base power. This part is going to come over here, so I'll have E over 10 to the 11.8. So we're almost done. We just have to get E by itself. Well, once again, multiply by the denominator. If I multiply both sides by 10 to the 11.8 power, this pair of 10 to the 11.8s will cancel out. That will leave E by itself. And just put this in your calculator and you're done. So what do we have here? 10 to the 7.35 power times 10 to the 11.8 power. Okay, so let's go ahead and round this to 2 decimal places So 1.41 times 10 to the 19th power. Okay. Now, when we were doing this in class, I saw many students wanting to leave off the 10 to the 19th power, like maybe they just weren't noticing it, that it's there. But that is part of the answer. Don't just put 1.41. Alright, if you leave that off, okay, because this is a number that is so big that it doesn't come anywhere close to fitting on your calculator. That's why it had to be written in scientific notation. Alright, if you knock that part off and just put 1.14, that's a really tiny number, you've completely lost the meaning of the answer. Alright, anyway, that was number 7. Number 8, the magnitude of another earthquake. So, once again, we're still dealing with the same Richter scale formula, which is this. So hold that in your mind. And we're told that it's a 9.0 magnitude. So once again, that's going to go where the M is. Okay, so 9.0. So that means we have 9.0 is equal to 2/3 log E over 10 to the 11.8. Okay. It was the strongest hit Japan, one of the top 5 largest earthquakes in the world since they began keeping records. How much energy was released by this one? Alright, so it's really the same problem as number 7 over again. So I'm going to go through it very fast. So multiply by the reciprocal. So that goes away. 3 over 2 times 9. Okay, that doesn't really reduce nicely for us. So 27 over 2, well, let's see. 13.5. Let's just use that. (13.5) is equal to log E over 10 to the 11.8 power. Time to rewrite this in exponent form. Understand there's an invisible base 10. Bring down that base 10, so I've got 10. These parts switch sides. So the 13.5 comes over here, and then the E over 10 to 11.8 comes over there. Got to get E by itself, so multiply both sides by 10 to the 11.8. Okay. 10 to 13.5. Okay. 1.995. If I round this to the nearest hundredth, I'm going to have to round this up. So 99 will go up to 100. So really, it's like this 100. If you look at the 199, this 199 is going to go up to 200. So 1.995 rounds up to 2.0. Times 10 to the 25th power. Do not leave that off. Alright, that is how much energy was released in ergs. Okay, so that's number 8. Now, number 9. How much stronger was the 2011 earthquake compared to the 2003 Georgia earthquake? Alright, and we're given the hint to just divide. Okay, so let's do that. Okay, so we will do the Japan earthquake divided by the Georgia earthquake. 1.41 times 10 to the 19th. Alright, I'm curious to see how our TI-30XS multiview will handle this. Okay, so this is how many times stronger it was. Alright, it's over 1 million. It's almost 1.5 million times stronger. That's a lot stronger. Alright, number 10. An earthquake released this many ergs of energy. Find the earthquake's magnitude on the Richter scale. Alright, round your answer to the nearest tenth. Alright, so we're just going to use the formula that we've been doing. So the magnitude should equal 2/3 times the log. Alright, and up here we put the energy. So that's 1.4 times 10 to the 15th power over 10 to the 11.8 power. So we should be able to put this whole thing in our calculator, and that's it. Okay, so 2/3 that can't be right. I must have done something wrong. Oh, I forgot the log. Wow. Alright, let's see. I wonder, can I edit this? Alright, silly Burton left out the log at first. Now I stuck it in there. Let's see if this makes more sense. Okay, so this earthquake was a 2.2 on the Richter scale. All right, number 11. What's the concentration of the hydrogen ion of vinegar if it has a pH of 2.5? Okay, well, the pH formula is a really simple one. pH is equal to the opposite of the log of the hydrogen ion concentration. So if the pH is 2.5, that goes right there where it says pH. So 2.5 must equal the opposite of the log of the hydrogen ion concentration. So we're supposed to be finding this hydrogen ion concentration. So the first thing you need to do is get rid of this minus sign by, you can think of it as either multiplying both sides by -1 or dividing both sides by -1. It doesn't matter. Bottom line is the signs will change. So -2.5 and then positive log. Okay, so if I need to get this hydrogen concentration out of there, I'm going to need exponent form. What is the invisible base here? It's base 10. If you bring down that invisible base 10, and then reverse these two things, including the negative sign. So this will be negative 2.5. And the hydrogen ion concentration will go over here. So this is the answer. We just need to write it in standard form. Just put it in your calculator. Okay, 10 to the negative 2.5 power. Big yawn. So there it is. 0.00316. Okie dokie. Artichoke. Okay, number 12. Okay, looks like this is the last one. What is the pH of an aqueous solution when the concentration is blah blah blah? Well, using the same formula, pH is the opposite of the log of the concentration. So the pH will be the opposite of the log of 9.3 times 10 to the negative 8. So guess what? Just put that in your calculator. By the way, this is small p, big H, like lowercase, uppercase. Okay, this pH of 7.03. That is it for this lesson. I hope it was helpful. I hope you were not using a pencil. I will see you on the next video.